Friends, welcome back to my channel. In this video we are discussing forward converter. It is single switch forward converter. It can provide up to 250 watt power. It produces the load current when this MOSFET is on, and it demagnetizes the core using this tertiary winding or reset winding. Let's see in detail how this converter is working, and we will see the timing diagram. When we say forward converter, it is a modified form of buck regulator. I discussed in my last video. In buck regulator, when we apply turn on time to this switch, it allows to flow the current through this inductor. This inductor provides inductive reactance and it stores magnetic field. Linear current increase will there in the inductor, and we will receive dropped voltage due to this XL. In turn off time, when we will stop the current, the stored magnetic energy will collapse. Magnetic field will collapse. It will provide reverse EMF. So this end will become negative, this end will become positive. So this freewheeling diode will allow to charge the current, so the current will remain in the same direction. First from positive to this direction, and now this end is positive, and now through this path. Let's see the similarity between buck regulator and the forward converter. In forward converter, we have positive voltage and the negative voltage. We have a primary winding. The difference between buck regulator and forward converter, that it have isolated output. We connect a switch, MOSFET, IGBT, transistor. It is in different configurations: single switch, double switch. This primary, it have secondary winding. It is step down converter. Normally it is used up to 250 watt with single switch. If we need some 250 watt output, so that time this converter is used. The combination of the winding, primary winding and the secondary winding, that these are in the same direction winding. Sorry, here we have this inductor, and here is load. When we apply a pulse here in the turn on time, this is turn on time, what will happen now? This is negative and here is positive. So a current will flow in the primary. It will create magnetic field, and this magnetic field will cut to the secondary because it is in phase winding. So this end is positive, this end is positive. When this end is positive, this diode is forward biased, so we will receive current flow in the inductor, so it will charge this capacitor and the load. We have this inductor. The current will flow, IP, primary current will flow in this winding. This current will increase linearly. Why? Because we have inductor here, XL, IP. When we are producing voltage in the secondary, there is current flow. So this current flow is in the same direction. This end is positive, this end is negative. So due to load, due to this inductor, there will a current flow. This current flow, secondary side current flow, will cause to induce same polarity voltage, so it will cause to make more stress here, so which will cause to more current flow here. That is called magnetizing current, IP, and the reflected current by the load. If there is high load, It will cause to induce more voltage. One supply we are providing here, and the second voltage will cause that are reflected from the secondary side. So IP plus the load current, because we are driving the load in the same time. In flyback, we store energy, and at that time the secondary side remains invisible, because in flyback this diode is reverse biased. But here the diode is forward biased. So magnetizing current will needed here. In the primary we will see increased current. Now when there is turn off time, in turn off time this switch is off now. Before this end was positive, this end was negative. Now the magnetic field stored in the inductor in the core will collapse. When it will collapse, it will produce voltage here, that this end will become positive, this end will become negative. Here we have positive, negative, positive. So we will receive double stress on this transistor. To demagnetize this core, there is no snubber circuit. For that purpose, there is an other winding in the same transformer, that is called reset winding or tertiary winding. But the difference here in this winding, primary winding, and this tertiary winding, reset winding, that these are opposite to each other. See the turn on time. When this transistor is on, at that time we applied positive voltage here. This end is open because diode is reverse biased. No current will flow in the on time. But when the magnetic field will collapse, this end is negative, this end is positive, so this winding is opposite, because dot end is here, so negative voltage will here and this end will positive due to winding polarity. Now this diode is forward bias. Now there is another current flow from here in this path. It will cause to discharge the core. When the current was flowing, this end was positive, this end was negative. Same time this end was positive, but diode was reverse biased, so this winding was off. There was no current flow. When the magnetic field collapsed, current stopped here. This end negative, this end positive, and in reset winding, in tertiary winding, this end is negative and this end is positive now. So it will cause to reset the winding. It will demagnetize the core. But now at this time, this voltage plus reverse polarity voltage by this coil plus the leakage inductance spike, so we will receive more than double voltage than the battery voltage on the switching device. So this device will take approximately 2.25 times stress than the Vin. So we need approximately 2.25 times more blocking voltage for this device. Now come to the secondary side. Before this end was positive when the current was flowing. When it was in conduction, this end was positive, so negative current will flow from load, so this inductor will store magnetic energy. It will provide a load current, linear increasing load current, same as buck regulator. Now when core is demagnetizing, magnetic field is collapsing, this end will become negative, this end will become positive. That time this diode is reverse biased, so current stopped. Magnetic field here will collapse. Now this end will become negative and this end will become positive, because collapsing magnetic field will produce reverse voltage, reverse EMF. There is a freewheeling diode here. This end is negative, so current will flow in the same, because this is now coil this end, inductor this end is connected to positive terminal of the capacitor. Before this, positive voltage were passing through diode, through inductor and reaching here. Now these voltage are stopped. There are no voltage. This time the magnetic field collapsed. This collapsing magnetic field will cause to flow this current. Before this current, in turn on time we have this current, and now this current. So we will receive load current like this. In on time, these are our voltage level, and in on time it will work like this. In the off time, magnetizing current will decrease, and then in next on time it will start to increase again. Let's see the timing diagram. Here we have primary winding. So diode can be connected here or here, it is the same. If we see in the positive side, the diode is reverse biased. If we see this circuit, diode is connected here in the both conditions. If we apply negative voltage to anode or positive voltage to cathode, it will remain same. When the switch is on, it will allow to turn on this transistor. In the on time, there is primary current on time, and same time due to load we will receive magnetizing current, that will be primary current plus the load current, because it is reflected back load on the MOSFET, because we are driving the load directly from the turn on time. When this turn on time will end and the converter will in off state, we will receive double stress on the transistor. Why? Because in the primary normally we receive positive voltage, but when the magnetic field will collapse at that time, it will produce reverse voltage here. That is applied voltage plus the reverse EMF. So we will receive double stress on this transistor. Here is primary current and magnetizing current. That is due to this load. In turn on time, the transistor will receive double stress. In off time, it will receive normal voltage that are here. But in off time, we will receive double stress to V in, double to the input voltage. Here is V in and here is 2V in, double to the voltage stress, because the magnetic field is collapsing. And this increasing current, that is ID1, that is from diode number 1. So this current is due to this winding, secondary side winding, because it will drive the load. But ID2, that is freewheeling diode current. When this magnetic field will collapse in this inductor, because that time this area is invisible, so just only this diode is visible in the circuit, so current will flow here. So this is the working phenomena of this forward converter. It is single switch forward converter. There are also different types of this converter, double switch. We will see in upcoming video how that will work. The conclusion, that we drive the load during turn on time, and this load current will create stress on this switch in the on time. When it will turn off, the collapsing magnetic field will cause to produce stress double to the provided voltage by the battery. If here is 300 volt, in the off time this transistor will receive more than 600 volts, because this voltage plus this voltage plus the leakage inductance spike of this transformer, so it will be more than 2.25 times to the Vn. Reset winding or tertiary winding is used to demagnetize the core in the off time. So the core will demagnetized and it will become ready to the next switching cycle. In the on time, this diode will provide load current. In the off time, this diode will provide load current using freewheeling effect. If you have any question, please write in the comments. If you think this video is informative, please hit the like button. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.